Hi there and welcome to this Godot course in which you are going to be creating quickly the game that you're currently seeing on screen. This course is short and beginner friendly, so even if you have never created a game before, you're going to be able to end up having a complete game. Let's start right away. So in this new course chapter, what we're going to be doing is downloading Godot, which is the game engine that we are going to be using for this course, as well as creating the project and start to import our assets, okay? So first of all, what you have to know whenever you are downloading a game engine is that there are going to be lots of versions. You tend to have the latest version, the stable version, whatever, but also you have some versions that are being tested right now. For example, you can see that currently the latest version is Godot 4.4, but there is also a dev version which is Godot 4.5. So to try to keep this course updated to the latest Godot features, I am going to be using 4.5 Dev 1. However, I believe that you're going to be able to just follow along with the course with mostly any version that you download, because it's going to be quite simple what we are going to be creating. So if you don't find this exact post over here, because this could be old when you actually take a look at the course, what you can do is over here, you can go to on a previous version, okay? And here you should be finding some part that says Godot 4.5, and in this case, we should be downloading 4.5 Dev 1 that was released on 20 March 2025. We click over there, download, and over here we select our platform. In this case, we want Windows, and we download the standard version, because the .NET version, which is this one, this has support for C#, which is another scripting language that we are not going to be using, so we are going to be just fine with the standard version. So we click over there and the download will start. Now you will have to extract this file, which is quite simple. You just have to firstly left click on it to be able to select it, then right click. And then over here, well, you may find an option if you are on Windows 11 to directly extract all, okay? Or maybe you find here a button that says 7zip or WinRAR, which are two softwares that allow you to do exactly this, to extract files. I'm going to be doing this with WinRAR, but once again, just use any software that you probably already have installed on your PC, or look for some kind of button that says extract. Here you're going to press extract, and you will find two programs here. One that doesn't have this icon over here, this black icon. This one is the actual Godot, okay, the actual program that we need. This is the console. This is something that we won't use at all. This is just for more advanced stages, so we can even just delete that file. And with this file, you can keep it wherever you want. You can put it on your desktop, on your toolbar, wherever, but just keep it somewhere. And when you double click it, well, probably if you don't have any kind of project over here, you are going to be seeing this completely empty. First of all, let's go to maximize this. Don't worry if you don't see any kind of project over here. So I am not going to explain all the interface here. We are just going to right away go here to create the project. Also, if you want to download the source code of the project, it's available, so you can directly press here on import and select the folder in which you have downloaded the source code. But just to start with this, I'm going to just press create. The first thing I will have to give here is a name. I will just call this one game dev course, and I will just name it 1 hour, okay, maybe something like this. And then you will have to select a project path. So I recommend that you have a specific folder in which you keep all your projects. So in my case, I have it over here in a folder that's called Leta. And here I have all my projects, but in reality I have here another folder. Okay, this is just for my own organization, but the key thing here is to have a folder wherever you want with your project. So I will just select this folder on my case. And here you will just leave there create folder. It is completely fine, because if not, you are going to be having a problem. So you just enable that. And here in the render, you have 3 options, okay? You can read here more information on the right. We don't really care about the renderer at this early stage, so we can just go with forward plus, which is the default option. And the same thing with version control metadata. This is something more advanced. We don't care about that at this stage. And lastly, we can just go ahead and create. By the way, edit now, which means that as soon as we create the project, it is going to open up. So indeed, we do want that. So let's press create and wait a couple of seconds. And here indeed we are in Godot. Now do not feel overwhelmed by the huge number of Windows tabs that you have, by all these things that are happening over here. Don't worry, because by the end of the course you're going to be able to understand most of these things perfectly fine. I understand that as soon as you open something and you start to find dozens of windows, it can be a little bit overwhelming, but trust the process, okay? I am not going to tell you, okay, the sync window does this, the import window does this, the file system does this, the inspector, etc. I want you to learn these things as we actually use them. That's the easiest and most straightforward way of learning this in this kind of short courses. Now, the last thing that I want to do in this chapter is to download the assets. Now, what are the assets? The assets are basically the different images, even the audio, if our game had some audio. Basically all the resources, which includes images, audio, etc. So when you want to create your game, there are two main ways. You can either just download some of them, and when you download these assets from somebody that has created them, you can either pay for them or get them for free. Okay, it really depends on the specific asset pack. Specifically here on Kenny, okay, you will find dozens of assets completely free, so it's a pretty useful website. And in this case, we're going to be using these two asset packs, Pixel Platformer and Pico 8 City. So we are just going to be downloading these assets. Okay, I'm going to be leaving a link to both of these in the description down below, by the way. So I will just press over there, download. You can continue without donating any money. If you wish, you can do that. And the same thing with Pixel Platformer. Download, continue without donating. Now on your downloads, you will have these other two zip files. So I will just delete the zip file of Godot. You can delete that. The important thing is that you keep this file. And what you will do with this is once again extract them. But what you will try to do here is to extract them to their own folder. So basically, if you double click on them and you open them up, you will see that, well, you have lots of things here. So if we were to extract them just like this, as we did before, it is going to everything like get kind of messy. So a much better way to do this would be to do the following. I will just create a new folder over here and call it Pico 8 and another one for Pixel Platformer. Okay, I will put Pico 8 here and Pixel Platformer here. And I will just go ahead here and in Pico 8, I will right click and I will do the same thing that we did with Godot. So extract here. There we go. Now I can delete this zip file. And let's do the same thing but with our Pixel Platformer. So right click, extract here. Here we have all the files, so now we can delete the zip. Now, how do we exactly import this inside of Godot? That's quite simple. What we'll do is that we'll select both of these files and we're going to directly cut them or copy them. I will just cut them over here and you will have to navigate to where you have your project folder. In my case, it is exactly over here, so I will just go ahead and directly here paste my assets. Okay, so let's give it a second and there we have it. Once we come back to Godot, you will need a couple of seconds to leave Godot to load in everything fine and to import all the assets, and you will just be able here to in the file system. So this is the first window that we're going to be taking a look at, which is the file system that basically does that, renders, or not renders, but shows the files within your project. So in this case, we only have these two folders within everything that is inside of them, and also the icon that this is a default file automatically created. So I know that you have lots of things here, but we're going to be breaking them down as lessons go by, because most of these things we are not going to be using them over here. But well, at least right now you do have your assets completely imported into your Godot project. And with this chapter is finished. And well, in this chapter, I want to super quickly give you a brief overview on how to ideate properly, on how to create a good game design. Of course, game design is a topic on its own and it will require its own course. And also, the game that we are going to be creating is quite simple, okay? But well, in general, these are the different things that your game design document has, or at least the most important things. So the first thing that you should have is firstly a reference of what you want to create. In this case, what we want to create is something quite similar to this game that you maybe know, that is called Crossy Road. Okay, so we want to create something slightly similar. So the first thing that you can have here is basically a reference, okay, to what you want to create. And this can be anything from a screenshot of a game, a mockup that you have quickly drawn in Paint or wherever. But you should always start off with a reference. Then there should always be these different things and even more stuff, okay, that we could add, okay. But these are like basically the core. These three things, okay, we could define them as the core of our game. So now we'll change color. So which is the core made of? Basically the game over condition, the win condition, and the game loop. Okay, there could be of course more stuff, but I just want to teach the basis. So for the game over condition, what has to happen in order for the game to end? In this case, in this game, of course, if we collide with a car, we've died, okay, and we have to start over again. And the win condition is just the opposite. What has to happen in order for us to win? In this case, we have to cross the road, of course, without colliding with the car, which is our game over condition. And then also something that is usually helpful to define is the game loop. And this basically defines how the game behaves after completing one level, or the game loop itself. I don't know if there is like a formal definition that could help you understand this, but this is meant to be, okay, is this a story game, so you may have chapters? Is this a casual game, so it is going to be infinite and it's going to be looping levels? Will this have manually levels made by us? So in this case, the only thing that we are really going to be having is one level, and this level is going to be manually made or built. Because of course in this type of games, what you could have is basically levels, okay, that are built procedurally, basically made by the computer itself. But well, in this case, we are not going to be doing that because that would take much more time. And then I also like to leave some space for extra comments. In this case, that this is a quick a quick prototype. So the focus, okay, is going to be on the core. So the focus on this project is going to be on this specific mechanics. We want to be focusing a lot on stuff that is not the core, okay? We are not going to be adding stuff that is not usually considered in the core, such as sound effects, which is usually identified as SVX. We are not going to be adding neither VFXs or visual effects such as particles, etc. We just want to really focus on these initial things, okay? And of course, then with the knowledge that you gain with more courses that you can watch from me or from other amazing creators, you may be able to focus more on other mechanics. Of course, the core can be bigger. Of course, the secondary mechanics, there are much more, but I just want to give you a quick overview on this. But well, this is something that you should always take a moment before creating any kinds of projects. Of course, the bigger your project is, the longer this document will be, and the more stuff you will need to put inside of it. But I believe that this structure for something super simple as we're going to be creating is going to be more than enough. So in this new chapter, we'll actually get to create a player that is going to be moving around, okay? So we'll start off coding, creating stuff here in Godot. So first of all, let me quickly explain you these tabs over here at the very top. So we have, as you can see, 1, 2, 3, 4, 5 of them. Quite simple to understand. 2D, okay, basically for the 2D environment. 3D environment, we're going to be focusing on the 2D environment for this course. The script tab, where we're going to be able to write our code. The game tab, we're going to be seeing this tab when we are actually playing the game, and we're going to actually be seeing this in a second. And then the asset library, okay, and this tag in particular, we're not going to be using it here. This is exactly that, an asset library with tools, scripts, and more stuff. But well, this is something that we want to be using. So I have just switched to the 2D environment, that is of course playing games. And I want to start creating the player. So where exactly do I start? And you have to start directly here on the scene view. And this is the place in which you basically create the different elements that will have your scene. So here, for example, if you had a main menu, well, you would have your background, your text that says welcome to the game, a play button, etc. So here is the place in where you're going to be seeing those things. But in this case, we want to create a player. So how exactly are we going to be creating this player? So we have some pre-made options, a 2D scene, a 3D scene, or a user interface, but for a player, sorry, we don't want any of these options. We want to press on other node, and what we want to do here is to search for any kinds of node. And what is a node? It is basically the basic creation unit of Godot. I know that we have sounded a little bit complicated, but it's easier than you may think. Basically, anything that you want to create in Godot is a node. So let's say that you want to add audio to your game. Well, then you have the audio stream player node, which basically does that, plays audio. If you want to create a user interface, then use control nodes, because here you have some labels which are used to display text. You have panels, you have, let me find the buttons, that should be right over here, base button, you have the button. And for creating a player, it is the same thing. Here in the search bar, I will type the following, character body, which as you can see is inside of the node to this section. So this is correct. You can also see that it has its equivalent in 3D, but in our case, this is a 2D game. So let's press create. And now, as you can see in our scene tab, we now have our character body. So we can rename this node. There are lots of ways of doing this. You can either double click on it, okay, and rename it. You can right click on it and select rename, or even use the shortcut F2. But to use that shortcut, you first have to select it with your left click. So I left click F2 and now I can rename it. And let's basically call it a player, okay, as simple as that. So why exactly did I choose to use a character body 2D? If we go back to the add a child node tab, okay, here you're going to be able to read a description, but it is not something that maybe you will understand right now. The important thing is here, a 2D physics body specialized for characters moved by script. So this is pretty useful for exactly this, a character that we want to move via script. What is a script? It is basically a file or the file in which we write the code, and that code will define the behavior of our object or our node. So indeed, you can think of nodes as if there were basically game objects. And before moving forward, and I want to explain nodes with a practical example, because I know that the first time that you hear about this, it can be a little bit complicated. Let's start off by saving the scene, because it's currently unsaved. So let's go here to the scene tab, and let's go to save scene. Now over here, we are going to create a new folder with this button, so we just keep everything nice and organized. I will call it scenes in lower cases, because it's recommended that the folders that we create ourselves are named like this in lower cases. It is just a recommendation by Godot. And right here, I will save it. And now for you to understand this nodes logic a little bit more, I want to quickly show you a project that I created myself on Godot. This is a much bigger project. As you can see, it has many things. But for example, here in the menu scene, well, we have a background, we have the title label, we have the play button. You can understand those things. I also have an animation player to be able to play different UI animation or user interface animations. Okay, so you can kind of understand where this is going. Or if we go, for example, to the player scene, well, we can say it is, of course, it has a character body, and it also has other things that we're going to be seeing throughout the course. For example, it has the animated sprites, which as you can see is basically, well, the sprites of the player, the image of the player, which is also animated because as you can see it has different animations. It also has a collision shape, which is basically the hitbox of the object itself. And then the audio of jumping, okay? So I believe that with this example, you can understand much more what nodes are. So what our player is going to be needing, okay? First of all, it is going to be needing a sprite to render images. We saw that the player from the previous game had an animated sprite, but in this case, I want to keep things simple. I want to get into animation, so we'll just use sprites, which is the same thing as animated sprite, but sprite is not animated. They work pretty similarly. And here in texture, okay, you can load the texture itself. And if we go, well, to the assets themselves, if you double click to any of these files, well, you're going to be able to see them right over here. And well, here we have some players here at the right, as you can see on the bottom right. And I believe that here in Pixel Platformer, you also have over here on sample A, I believe that you also should have there some players, so you can actually use any of these. Here you have characters, so you would be able to use any of these characters, okay, that you may want. But how exactly? Because for example, here in Pico 8, you have this thing called a tile map, which has like lots of things. But you also have the tiles, which are the individual tiles, exactly that, okay? So in this case, I will just go to the tiles, okay, and find a player that I like. But once again, you can do this exact same thing with any of the characters that you may find over there. So let me actually look for any of these players. So let's use this guy over here, okay? So let's press back on sprite, and here on texture you can drag and drop any of these sprites. There we go, and we can zoom in, and the first thing that we see is that everything is blurry. So we just have to go to texture, filter, and select nearest. We have to do it like that because this is pixel art, just because of that. And by the way, we have not really talked about the character body, but we're going to be talking about it and the advantages that it provides with the following lessons, basically. Now also, something else that you may have noticed is like that our player is super small, because if you take a look at these blue lines, these are our window, basically, our game, and well, our player is super small. So we have to go to the sprite, go to transform, and scale it up over here with the scale property. So we can put it something like 10 maybe. Yes, I think 10 does look good. And well, I will start with this just in the player, then we'll also add the collision shape once we get to add the collisions, but with this we'll have a pretty good setup to start off. We'll see that, for example, in the character body, okay, we're going to be having here a warning. This node has no shape, so it can collide or interact with other objects. Why is that? Because it doesn't have a collision shape. So basically, this player is not going to be able to, for example, detect collisions with the cars or with coins if there were, wherever. It is just a plain image right now. So to start off understanding this character body a little bit more, this is a node, okay, that will allow you to detect collisions with. If you actually go here to the other child node, which by the way has its own shortcut, which is Ctrl A, so I can be over here, press Ctrl A and add it, or select the player and add it. If I delete the search and go to 2D nodes, what you're going to find here section is a section called collision objects. So all these objects that you have over here, static body, character body, rigid body, area, 2D, etc. These are all objects that will allow you to detect collisions. Now we have lots of objects that you can use for this. We are not going to be digging deeper a lot into all of them, the differences, etc. But well, this is the basic explanation. These are the only objects in Godot, at least in the 2D environment, that are able to detect collisions with. This is why we used a character body, which is, as you can see, a collision object type, because if not, then we wouldn't be able to detect collisions with our player. Once again, this doesn't have to make sense right now. It will make sense once we start adding collisions. And now the last thing that I want to do for this chapter is to go ahead and add our first script. Now, to add a script, firstly what you have to know is to which node you want to be adding this script. Now, for your player in this case, you want to attach it to the root node, because the node to which you attach the script, it is going to actually only modify the behavior of the node that you attach this script to, basically. If you attach the script to the player in this case, it is only going to affect the player, and in this case, any of the children that it could have, in this case, the sprite. So whatever we put inside of the player in terms of script, it will affect the sprite, then the collision shape, then everything. Because a mistake that probably as a beginner you have made, or well, maybe you have not because you have not done anything in Godot yet, it could happen. But is that when you attach a script, you attach it to the sprite, for example. And it's not the same, because if you attach the script to the sprite and you create a movement logic, what is going to be moving around, okay, is going to be the sprite. Okay, but in reality, if we now go back to a character body, the character body is in the initial position. So you can, and this can lead to like lots of problems. So always check that you are attaching the script to the corresponding object, and to go back, Control Z of zebra, or if not, go to scene and sorry, project, where was it? To go back over here, there wasn't a button here. Yes, here it is. Undo over here, Control Z. Okay, so we select the player, attach a script, which is this button right over here. Now here have lots of things. Language, as I told you, we are on the standard version, so the only language available is JavaScript. You were also able to download the other version that had C# support, but we are not going to use in C#. In here it basically says, okay, which is the parent node of this script. It is character body, so you don't tend to have to modify this. And you also have a template here. And in this case, specifically for character bodies to this, you have this template, which is basic movement. So with this, we can just start having our movement. So this is pretty cool, and built-in script, we are not going to be covering that because it's a more advanced feature. Now for the path itself, as you can see, it is going to be saved inside of the scenes folder, and that's not correct. We should have a scripts folder. So we can click on this folder icon. We can go back with this button, and we can create a new folder over here. So let's call it scripts. Open, and once we check that everything is fine, create. And this will put here a lot of code that we are going to be analyzing in our following chapter. Indeed, in this new chapter, we are going to be covering how to understand this script properly. And in reality, we don't have to understand it completely right now. It is going to make sense, more sense as the course goes by. So basically, we have here two constants, which means that they are basically two values. Speed is equal to this, and the jump velocity is equal to this. These are values that are being stored in the game memory, quite simple. In this case, these are constant values, so their values themselves are not being modified. They always keep constant. That is why they are constants. Later on the course, we are going to also be seeing variables, okay, which are the same thing, but their value can vary. I don't want to overwhelm you with all these concepts. For now, the only thing that you have to know is that these two things that you have here are values. And these values are used in different places of the code. For example, if we double click on speed, we should be able to see highlighted the different places in where this is used. This is used in this case over here and over here. And the same thing with jump velocity. It is used over here. So the other thing that we see over here is func physics process delta float void. What is all this? So basically, the func keyword defines that there is a function that is starting. And what is a function? What you have to know is that there are two types of functions. So first of all, you have built-in functions, which are, for example, this one, physics process, and you have user-made functions, okay? So built-in functions are the ones that their behaviors are set, so you can't modify what happens. And the user-made functions, as they are made by the user, by us, basically, their behavior is not set. The behavior is customizable. Once again, these are lots of concepts, so it doesn't have to make sense right now. So what happens here is that physics process is a built-in function, so it already has a behavior, and which is its behavior is basically being called all the time. In reality, you can read the tooltip over here, called during the physics processing step of the main loop, basically called all the time. So once we have understood this, we can move forward. So this function is called all the time. What else do we have here? We have parentheses, and instead of the parentheses, delta float. What is this? This is an argument that comes with the function. We are not going to be digging deeper into delta because it is a more complicated topic, a more advanced topic. But what you will see is that delta is always used, well, in this case, for when we want to modify the velocity. In this case, we want to add the gravity, so here we multiply this by delta. And this is just to make it frame rate independent. Once again, I don't really want to be explaining lots of things here. The delta parameter is a topic on its own. I will be linking for any of you who want to read deeper into delta. As you can see, it has its mathematical explanations, why it works, why it's important, etc. in this article over here. Once again, link in the description. And well, the rest of the code is quite easy to understand because it is commented. And by the way, this thing over here means that this function returns nothing. In reality, functions can return values. So just for you to understand this quite simply, I will create a new function that I will call sum, and I will just return over here an integer, for example. And as you can see, it's also indented over here. This is automatically put by Godot, but if not, you just press tab on your keyboard. This means that whatever you write over here, it is going to be inside of the function. This line over here is not inside of the function, doesn't belong to it, but this line does, okay? So in this sum function, we could return, I know, 1 plus 1 with this return keyword. So it's basically that. This means that the function does return a value. This is a pretty basic usage. Returning values, we are not going to be using it either on the course, but just for you to know that. Now, moving forward, this code over here is going to be adding the gravity. So this is checking over here if we are not on the floor, which means that we are, for example, here basically flying around, then we are not on the floor, of course. So we want to here apply gravity basically. Yes, there it says grav. And in this case, this gravity is applied with this code over here. Then, you know, to handle the jump, it is quite similarly. It's quite similar, just that what we check for is an input. So in this case, we check for UI accept, which is the spacebar of our keyboard. And also something important is that we are only going to be able to jump if we are on floor, okay? So if we are here and we press the spacebar, okay, we jump basically. But if we are over here, so we are not on the floor, and we press space, we do not jump, okay? Nothing happens basically. Because if not, we would be jumping in the middle of the air, and that's something that probably you don't want. And here once again with this code, using the jump velocity value, the jump is applied. Now, these other parts of the code could be a bit complicated to understand, but not really. With this variable over here, what we have to know is that we get the input direction. And for you to understand this, what I will do is that below this line, I will add a print statement. So I will type print parenthesis direction, okay? Just that. And then here at the top, I will press on this button which says run current sim. And what I will do is that I will see my player just go down, and I will also see over here 0, 0. This is the direction that is being printed. If we press the right key, the right arrow on our keyboard, and we keep pressing it, we have 1. If we don't press anything, we have 0. If we press the left arrow, we have a -1. So that's exactly what this code is doing, detecting whether we are pressing left or right and calculating the direction. Because this is the same as in maths, okay? If we have the x-axis, okay, and this point here is 0, whenever you move to the right, okay, you have positive values, and whenever you move to the left, you have negative values. So if we return -1 when we are pressing left, the left arrow, it makes sense because we want to move left. And if we return +1 when we are pressing the right key and we want to move right, that's once again correct and the behavior that we want. Now let's delete this line over here. And then what these last pieces of code are doing are the following. Here this says if direction. What does this mean, if direction? This basically means if direction is not 0, which once again, remember, if we had 0 in direction, it meant that there was no movement, there was no keys that were pressed. So this means that if there are any keys that are being pressed, any movement keys that are being pressed, we basically move, okay, using the direction and the speed. Remember that we were returning 1 or -1, but actually imagine moving just 1 unit at the time. It would be super slow. That's why we multiply this by speed to be able to move much faster. Rather than moving just 1 pixel per second, we are going to be moving 300 pixels per second, so it's much more. It's 300 more times. And else, which means that if we are not moving, what Godot does here is it basically deaccelerates. So it linearly moves towards our velocity, okay? It moves it towards 0 basically. And like that, we have like a smooth deacceleration made. But in reality, if you don't understand what this is doing, it's basically doing this, setting velocity back to 0, okay? So a quick recap, if there are any keys pressed that the left or right keys are being pressed, we move. If we are not moving, we just reset velocity to make sure that our player is not being moved, okay? And lastly, move and slide, the only thing that it does is that it actually applies the changes that we have done to the velocity. I know it has been a little bit complicated, but trust me, it is going to be easier than it may sound right now when we go over these topics over and over again in the course. So in this new chapter, we'll actually be able to create our player movement. And first of all, what you have to know is that there are basically two types of player movement into the space. So you firstly have platformer type movement. So this is type of movement in which you may have a ground, a platform, or wherever. I will call this thing G. Okay, so this is our ground, and here we have the player. Okay, and the player can basically move left, right. It can even jump. And the key thing here is that this has gravity. Okay, so this is the type of movement that you may have in Mario Bros, for example, in Geometry Dash, for example, platformer movement, we can call it. And then there is other type of movement which is not platformer movement. It's the one that we have in Crossy Road, for example, in which the gravity is null, so we have no gravity, and we have once again the player, and the player can move in any of the directions. So it can move up, it can move down, it can move right, it can move left, it can even move in diagonals. Okay, it can move literally in any way that it wants. But once again, there is no gravity. That is the key over here. I have some of these examples on my portfolio. So for example, in this game that I created, Circle Combat, you can see this type of movement. And also in, for example, World Cup Collector, you can also see this type of movement. Whereas, for example, in Protect the UFO, you can see the other type of movement, the kind of platformer movement, because there is some gravity applied. So yes, indeed, the difference between one type of movement and the other is gravity. And basically, the type of movement that we are going to be having for this game, which is going to be, which one do you think that's going to be if we are going to be creating Crossy Road? Exactly this one, okay? The kind of static movement, or I don't really know the type of movement that this is called, but this is not gravity movement, definitely. But remember that our code does have gravity applied over here. So the first thing I want to do here is to completely delete the gravity, okay? And also something else, the player itself is not going to be able to jump, okay? It is going to be able to, of course, move up and move down, but it's not jumping, it's just moving. That's why we also have to delete the logic of handling the jump. And also we can delete the jump velocity because we are not going to be using it at all. So let's start to see what we currently have over here. Let's select the root player node. Do not select the sprite itself, select the player so that we move everything. And we can just drag this over here. But as you can see, I have selected the sprite. So I have to select the player and here use the move tool. So with this, I move everything, as you can see. And now I will just run the current scene. And here I have the player, and what happens is that if I press the left and right arrows, I now have what I need, okay? A left and right movement, but I should also be able to move down and up, right? But well, we start to see the main differences between what we used to have and what we have right now. We have no gravity, we have no jumping, so it's kind of a static player movement. Once again, here we're going to be having lots of warnings, but for this time we're not going to be paying attention to them. So how exactly are we going to be able to move down and up? So first of all, let's go back to our script. And first of all, here, the thing that we have here is that as good practice, you should replace UI actions with custom gameplay actions. Because here, remember that to calculate the direction, well, we are doing the difference between the left action and the right action. This is basically what returns us what we have seen in previous chapters, -1, 1, or 0. But this is a UI action. So this is not meant to be used for a player movement. So we'll go to project settings, and here we go to input map. And if we turn on show built-in actions, we should be able to find, for example, UI left, here you can see it, and UI right. So what we want to do, first let's disable this and let's add a new action with this button over here. And I will call this one move left, okay, and I will press enter to create it, move right, enter. And in move left, what I'm going to be doing is that I will just click on the plus icon, and for moving left, in this case, I want to move with WASD. So left is going to be A, and I will press OK. Right, D, OK. And I also want to create the same things, but for move up and move down. So to move up, W, to move down, S. And by the way, you can add as many bindings as you want. So if you want to move left with A and also with the left arrow key, you can do that. But I don't want to do it like that. And now let's go back to our code and replace the thing. So instead of UI left, we want move left and move right. And the code like this is going to be working in the exact same way. Here as you can see, this is a yellow and we have a warning over here. This is because we have not used the delta parameter. So if we don't want to see that warning, let's just prefix this with an underscore and that warning is going to be solved. So now to get the direction, it's going to be slightly different. Let me first of all delete these lines, so we can just press on any of these lines, press Ctrl X, and they are just going to be deleted. So there we have it, and I'm also using just the arrows of my keyboard to move up and down. So for the direction, we have to calculate it slightly differently, because now we don't have just one axis, but we have two axes. We want to move in X and we want to move in the Y. So here, instead of move axis, we need one that is called get vector, which is going to allow us to provide also up and down. So after this, we provide move up and make sure that you are using these exact same symbols, then comma, space, and move down. Why exactly in this order? Does the order here matters? Yes, it does. If we put over here our mouse cursor, we find negative X. So once again, we saw the graphic there. Yes, indeed. To move to the negative X, we want to use the move left. To the positive X, okay, if we want to move right, okay, we want to use the move right. And here, this could be pretty interesting. We have negative Y and positive Y. And for the negative, we have put move up. And for the positive, move down. And this is quite interesting, because if we go back here to these lines, Godot, at least in the x-axis, works in the exact same way as in maths. So left is minus or negative, and right is positive. But in the y-axis, it is slightly different. It's the opposite as the normal logic or as maths. In maths, okay, what we have is that, okay, this is 0 and this is positive numbers and these are negative numbers. But in Godot, this is completely different. What we have is basically down we have positive numbers and up we have negative numbers. For different reasons, this was done like this in this specific engine. So that's why, as here the axes are basically inverted, we also have to invert here this. Because once again, okay, if we want to move up, okay, we actually have to go to the negative value. So that's why here as the third argument, which is if we put the mouse cursor over here, as you can see, the third argument is the negative Y. So for the negative Y, indeed we want to move up. And for the positive Y, which is the fourth argument, as you can see, we have put move down, because for the positive, okay, we indeed want to move down. It's the opposite as the logic. I know it can be complicated to understand, but this is also something you can see over here. If we go to the player node and we select it, and we go to the transform, and we go to the position, let's first of all reset it, and this is in 0, 0. And let's, for example, move to the right 30 units. Okay, it is to the right, now minus 30, it's on the left, completely logical. But if we go to the Y, if we put 30, you think it will go up, but it goes down. Once again, it's the opposite to the logic. And if we put it in minus, it's going to be on top. Once again, quite weird, but that's exactly how Godot works. And here what we have to do is that we are here having a problem. Value of type vector2 cannot be assigned to a variable of type float. So let's quickly recap what we were doing here. We were just modifying here the x velocity, but right now we are getting like the complete vector, the complete direction. So we want to modify the velocity itself, which has an x and y value. That's why it's a vector 2. It has y and x, or x and y actually. And the same thing here with the else, okay? And also here, when we want to move towards, here we just use velocity. Or in reality, here we should have we should use basically other function, okay? Or maybe here we can just put vector2 dot 0, which means vector 2 with 0 on 0. But here in reality we would have to use another function, which is vector 2 dot move towards, or it was something called like that, vector dot move towards. So I don't want to get this more complicated. So remember, if we are moving, we apply the velocity. If we are not moving, we just set velocity back to 0. And now our velocity is a vector 2. Well, it was always a vector 2 because it has an x and a y. our velocity. We want to move in both X and Y. So now when we run this scene, once again, press over here and not in play current and not in run project, those are completely different. And when we press the W, A, S and D, well, we have our player moving around and everything is working perfectly fine. Now in this new section, what we're going to be doing is actually adding a tile map, but before doing that and explaining what a tile map is, because basically we're going to be using a tile map to kind of draw the environment, basically draw the city in which this kind of character is going to be moving around. In order to understand that, we firstly have to take a look at scenes. Why? Because right now we only have one scene, which is the player scene. Okay, so let me actually collapse these files over here. And here we have scenes and we'll have the player scene. But how exactly are we going to be having our game with the player, the different obstacles, the tile map, etc.? So what we are going to be needing is a new scene for this. And in this case, it is going to be a 2D scene. Okay, and I'm going to rename it. So I will press again on this node and I will call it main. Then with Control S or go into scene and save scene, I will save it in my corresponding scenes folder, okay? And the idea is that in this scene, we start instantiating, okay, that is the technical term, to start putting, okay, to start joining up together the different parts. To do it, we're going to be clicking on this icon over here that, as you can see, it says instantiate child scene. And over here, we're going to be selecting the player. So now, as you can see, we have the main scene with the player, okay? And what will happen with this is that now we start to put any other component that we want into our scene, whether it is the environment, the obstacles, etc. And this leads us to the following that I want to explain. And that is that basically scenes themselves, okay, they basically have two main functionalities. So let me divide this like this and like this. We can divide them into one type, which is containers, which would be, for example, our main scene in this case. And the other type of scene could be a functionality scene, so func, I will just call it in this case. Which, for example, will include our player, and later on it will also include, for example, our environment, our obstacles, etc. And actually understanding all this is quite important for you to understand how we are going to be structuring our game and our project, because this is the way in which you actually structure a game inside of the Godot engine. And don't worry if you weren't able to understand completely all this. Once we get to add more stuff into our game, it will make much more sense. So now let's get to create our tile map. And for that, let's go back again to create a new scene. To get everything to be organized and taking advantage of the things that we have learned in the previous chapter. So let's click here in this button to add a brand new scene, and in this case what we're going to be creating is a tile map. I will be explaining why in a second. So for now, let's just click here on other node, because we don't want to be using any of the nodes over here that Godot provides us as a template, let's say, or as a shortcut. And actually here, let's look for tile map, okay? Exactly, tile map layer, because this one, as you can see, is deprecated. So the latest one is actually tile map layer, okay? Once again, this is telling us that this is unsaved. So let's go to scene, save scene, and inside of the scenes folder, let's go ahead and save it. Now follow along with me for just a second and everything will start to make sense. So how tile maps work is that you have to create a tile set. So first of all, let's create a tile set. Once again, I will explain all this in a second. Let's open this up. And as you can see over here, we have like some new buttons. So first of all, we have to click on tile set to actually create a tile set. And for this, we have to go to our assets and find any of the tile maps that we want to use. So for example, this is some kind of city that could be worth for us, or that this is inside of the Pico 8 folder, or also in Pixel Platformer here in tile maps. Okay, we would have some of the tile maps that we need. This is for the background, these are for the characters, and here this is for the platforms themselves. This is not going to be a platformer game, so really we're not going to be using this one. We're going to be using this one of Pico 8. So let's basically drag and drop this one. You can either use tilemap or tilemap packed. The only difference is that one is packed and the other one isn't. So I will actually be using this one because I don't like those lines over there, that spacing. So we can just drag and drop this inside of, well, first of all we have to go to tilemap, and here in tileset we have to drag and drop it directly over here on this dark blue rectangle. And here we just press yes to automatically create everything. And here we have the tilemap. So now for you to understand what the tilemap is going to be doing, it's going to be slicing the tilemap into the different tiles, okay? So for example, right now this doesn't seem to be quite fine, because if we wanted to select, I know, for example, these cars over here, they don't seem to be the correct size. The same thing with these kind of houses, okay? It doesn't seem to be working quite as it should. And this is because this has a certain tile size. As you can see, it also has some margin, separations, texture, region, etc. So in this case, what we would like to do is to modify the texture region over here to be something like 8:8. As you can see, with this size, it is going to be much better and easier to select the different tiles, okay? But now, as you can see, these ones have darkened over here. So what we have to do is to directly, for example, go to this bottom corner, hold down Control key, okay, and I will go down, up and in diagonal basically, so that I can select all the tiles, and all the tiles, as you can see, are going to be selected. So now when this has been done, we can go back to a tile map over here and select any of these. For example, I don't know, let's select here these ones to create some kind of house, okay, this one, and then holding down Control, I will select also this one. Then I will paint also that other roof, but let's just try this out. And as you can see, actually, when you do this, it's going to look quite weirdly. First of all, it looks blurry. So let's go to texture, filter, and select nearest. But now also the tile has a certain tile size. So we also have to set this to 8:8. And now as you can see, everything's looking much better. Now you can also scale this in, because as you can see, this is super small. So let's scale this into something maybe like 10, or maybe 10 is a little bit too much, so maybe something like 5 would be better. And let me actually erase this, because it's not going to be what we want to draw. So for you to understand a little bit exactly how time maps work, basically all these that you have over here, all of these together, okay, this is called a tile map, which is basically a collection of tiles. So each of these cells over here, or squares, or however you want to call them, okay, these are all tiles by separate. So these ones are called tiles. And basically tile maps on their own, they aren't pretty useful, okay, because if you just try to use this image as it is, it has no sense. What we need to actually use are tiles. So in order to use these tiles, okay, we use the tile map layer node, which, as we have seen, allow us to actually tile or section or trim, or however you want to call it, the different tiles inside of our tile map. Of course, mathematically done, and not like drawing on top of it, as I'm doing right here to just show you what I want to explain. And now, using a variety of styles, I will get to draw my environments. I will show you the final results so that you can copy it, but also feel free to draw whatever environment feels right to you. And also, by the way, we have some tools that would be helpful. For example, with this tool, you can paint a rectangle. So let me select, for example, I don't know, this shape over here. And with this thing, as you can see, I'm going to be able to paint in rectangles, so that doesn't look that bad. You also have this one that will allow you to rotate the tiles. So for example, let me select these 3, and I will just select here the paint tool. And well, this is going to be painted like this, but I can rotate it. So you can see that this is like as if you were drawing in Photoshop or in any other similar tool. So basically, if you want to take a moment to copy exactly what I've done, here's the moment to pause the video and take a screenshot. You can super quickly copy and paste that on your end. And now let's save our scene with Control S. And going back to what we were explaining a second ago of scenes, well, remember we have 2 types of scenes, the ones that are containers and the ones that actually have a functionality such as our environment. So now what we want to do to continue connecting our scenes is to select our main node and instantiate our tile map layer, okay? And here note something, our tile map is actually on top of the player, so we have to carefully put it in between both of them, okay? Exactly like this should be your final hierarchy. If for some reason you end up putting this inside of the player, this is not correct, you have to make sure this is right there. And also now what we can do is to just grab the player and start putting it over here. We can also scale it out a little bit because I believe it's a little bit too big, so we can go back to the player scene sprite, and here in scale, instead of 10, let's try out 7.5, and once again let's make sure our scene is saved with Control S, and over here this is in 7.5, so let's put it right over there. And now when we click here to run the current scene, we're going to find the player over there, and it's going to actually be able to move, okay, towards the end of the level. And also something that I quickly want to do over here is that I only want my player to be able to move horizontally but not vertically, because here the player will be falling like in the water. I actually show you how you can also like move vertically, just for you to know and to learn how to also create this type of controller, okay? So how are we going to be doing this? You could technically come back to the previous version of the code before refactoring it. Or even easier, we could come back here to the input actions. Remember to go to project settings, input map, and here delete the bindings, okay? I basically mean this, the keys, not the event itself, okay? Just the binding, okay? Because if not, we're going to have an error. So let's delete those two, move up and move down. So now the calculation is going to be the exact same one without having to modify any code. So now even if you press W, S or whatever, your player is only going to be moving horizontally. Now let's get to add our obstacles. So for this, once again, we're going to be needing a brand new scene. And for the root node, we're going to be clicking on other node. And let's first of all think of what we want our obstacles to do. We want our obstacles to move, and we also want to then be able to detect collisions between the obstacles, basically the cars, and the player. And if there is a collision between the two, then well, the player loses. So that's why we are going to go back to collision objects. That remember that these are the ones that allow us to detect collisions with. And once again, we have lots of them. We have static bodies, character bodies, rigid bodies, area studies. Let me super quickly introduce each of them. Static bodies are the ones that are not going to be able to be moved. That's why they are static. Character bodies, we have already used them. This is for objects that we want to move via script, usually players. And the rigid body is basically a type of body that has built-in physics. So if we wanted to add a ball that is going to be bouncing around, for example, well, a rigid body could be a pretty good choice. And last, we have the area 2D, which is basically just exactly that, an area, a space that detects collisions. So which of these four actually you would think that we would need to use? First of all, we will not use a static body because our cars need to move. We will not use a character body because this is not going to be a player. We could still use a character body, okay? But we wouldn't be taking advantage of the features that it provides because it's not a character, it's an obstacle. And lastly, the rigid body, it is not the option because we are not going to be using physics. And lastly, the best option would be area 2D because, as you can see, it is just a region of 2D space that detects other collision objects entering or exiting it. Basically, it detects collisions. That's the only function of it. So this is what we're going to be using. Once again, using different types of bodies can actually be a topic on its own, a course on its own. So as you create more and more Godot games, you're going to be able to understand more when to use each of these. So let's double click on it and let's just call it car. And let's go ahead and save this scene with Control S in our scenes folder. So in our car, I want to add a child node, okay? I just want to add a sprite over here and I want to be adding the car. But if we go to the tiles, you can see the car is cut in different pieces. If we select the first one, hold down shift and press on the last one, we're holding down shift and we drag and drop them, we're going to be creating new sprites. So as we have them all selected over here, let's go to visibility, to texture and filter in nearest, okay, so that they are not blurry, because remember, if filter is set to inherit, it's going to be blurry. So here we have basically the different parts of the car, basically. So here we have one car, and here we have another car. The only difference is that one is flipped and the other isn't, but they are the exact same things. So for this example, let's just use these two parts, which are 277 and 278. So these two, we can select this one, press delete, this one, press delete, okay. And here we will have our corresponding car, and we can just delete these sprites. In this case, we are using two sprites to just be able to kind of use them properly. So there we have them, but as you can see, they are not in 0, 0, so this could lead to some weird behaviors. So first of all, let me select these two, and I will to select the two of them, by the way, you select one, then hold down Control, and while pressing down Control, click on the other one, then right click, reparent to new node, and I will reparent them to a node 2D, and I will call this one sprite, just so that they have everything kind of in the same place. Now I will get my first tile, go to transform, reset the position, second tile, reset the position, and then in this place over here I will move the second tile to the right, okay, until it is right there. Why I have done it this way? Because now I can go to this node, transform, and scale it in, because this is super small, so maybe let's give scale of 4. And also, this is looking right, but in reality, in our game, well, the cars, at least initially, they are going to just be moving up. So we have to rotate our entire area. So let's go to transform, and in rotation, let's start to try out the different rotations. So in this case, it would directly be 180, would it be? No, it will be 270. There we go. It will be exactly going up. Now, if we go ahead and save our scene with Ctrl S, go to main, select the main node, and press instantiate, and we instantiate our car. Okay, and now we can put it wherever we want, such as over here. Okay, let's actually make it a little bit bigger. So let's select our sprite node over here and make it 5. Save the changes so we can see it reflected over here. Yes, even a little bit more wouldn't be bad, so maybe 7. Control S once again to save, and yes, there it does look quite good. Now we can select this node, press Control D to duplicate it, or you can also right click and press duplicate, and let's also move it here, for example. Okay, and let's start with just these two cars. But when we run the current scene, well, they are not moving, of course, so let's get to actually move them. And this is actually going to be quite easy. So first of all, let's go to the area itself, press attach a new script, and the path, as you can see, it would be saving the script into the scenes folder, and that doesn't make any sense. So let's go back to the scripts folder, open, and create. Okay, now over here what we want to type is basically func_process and then enter. So this is quite similar to the physics process function that we have used in our player, but in this case, remember that the player does have physics, okay? Or well, initially it did have physics, so technically we could use just here process. So indeed, the only difference between physics process and process itself is that one is meant for physics-related behaviors, and process is for non-physics related behavior. And in this case, well, our car is not going to be having physics, so we can directly use process. In this case, for this exact game, using physics process or process is not really going to have a huge impact on. It is a much broader topic, physics process versus process, but in this short course, it is not really going to be something that is inside of the scope. So for process, what we firstly are going to be needing is a constant, as we have over here. So let me just copy and paste it over here with Control C, Control V. So there I have my constant speed. And to actually move this car, it's going to be slightly different, because here we're modifying a velocity, but this is a value that only exists if the object is a character body. So here we have to do it slightly different. So what we want to do is to grab our position, and here type plus equal, which will mean, okay, to our current position, okay, just add what we are going to be telling it right now. So what we want to add over here is vector2.up, which basically means go up, okay? And we want to multiply this by our speed and by delta. What this will actually do is to just continuously move our object up at the speed that we have defined over here. Once again, down below is a resource for you to read more about the delta parameter, because it's a much broader topic. And basically this vector2.up, if you don't understand it, it will be the same as the direction. Here the direction is based on input, and here the direction is always going to be just move up. So now if we go back to the main scene and run the current scene, as you can see, the cars are just moving up, so that's amazing. But of course we have the obvious problem that, well, the cars have gone and they are not returning or anything like that. So let's get to actually polish a little bit more our obstacles. So for you to understand the logic, what I want to do is that when the car basically exits the screen, I want to teletransportate it, okay, to the initial position. So if the car was firstly put over here, this is the initial position, in this case 201, 650. Once the car exits the screen, something like there, it should come back to the initial position. That's basically what I want. So how exactly are we going to be managing this? Let's go back to the car itself and select the car node and press a plus, okay, to add a new node. And in this case, we want a visible on screen notifier 2D. And as you can see, this is a rectangular region of 2D space that detects whether it is visible on screen. So quite simple. So in this case, we have this pink box that we have to resize to match as closely as possible the size of the node. So let's basically use here the select mode to quickly be able to resize it. It doesn't have to be 100% perfect, okay? It has to be as close as possible to the actual shape. There we have it. And now we can press over here and go to a new tab that we have not seen before, which is the node tab. If we click it over here, we're going to be able to press on screen entered or screen exited. In this case, we want to double click on screen exited and press connect, and whatever we put inside of here is going to be executed when our car leaves the screen. And what do we want to do when that happens? We want to go back to the initial position. So how exactly do we manage that? So how exactly do we get exactly that, the initial position? So for this, what we need to get is, okay, as soon as the car is created, I want to get the position of it. That's going to be the initial position. Then that position is going to be updated, because remember that we are telling our object to go up, basically. So in order to do this, what we're going to be creating is a variable. A variable is super similar to a constant, but a constant value cannot be modified, and a variable value, it can be modified because it's variable. It can vary, okay? So let's just leave here some space, and you declare a variable with the var keyword of variable and then the name of it. So in this case, we're going to call it initial position, okay? And initially, I will just set this to vector2.0, which basically means 0, 0. Then we are going to, of course, be setting this properly. And so as I told you, we have to set this as soon as the game is run. So to do this, we're going to add in what is called an annotation. So we leave an empty space, okay, and here we add on ready, actually. And here, what we are actually going to be putting is equal to position. What this is going to be doing is to create a variable as soon as the game starts. So when the game is ready to be launched, it's going to create a new variable called initial position, which is going to be assigned to position, which is basically our current position. So once we have this, once the car has exited the screen, we want to make position equal to initial position, as simple as that. Now, once you make sure that you are on the main scene, you can run this code, and well, now when the car exits, as you can see, it returns to the initial position. Now, what we should also do is to make sure that our cars start outside of the screen so that it doesn't look that weird. So we just going to drag them outside of this kind of blue line over there that maybe you are able to see, maybe you are not. So let me just zoom in. This blue line, as you can see, it has to be outside of it. And now when we play, it's going to kind of look much more natural, that transition, okay? So it does look much better. Also, something else that you could do is to this car, for example, drag it down a little bit more, for example, so that they don't go at the exact same position, okay? So let's run the scene, and well, as you can see there, it does seem much different. And also, what if you want to add cars going down, basically? So what you could do is basically, once again, select any of the cars, press Ctrl D, okay? And well, let's just position this, for example, in this other road over here, and let's move it up, once again, outside of the screen, so it will be right over here, Inspector. And in the transform, we have to just modify the rotation. So this is a way to understand this. Let's just make this 0 and start trying out values. In this case, it will be 90. But if you don't really understand how rotations work, this is 90, this is 180, this is 270, and the initial position is 0, or it could also be 360, as you can see. So if you don't understand it, don't worry. You can just start playing around with these values and you will eventually get the rotation that you want, okay? But of course, try to learn rotations. It's not that difficult. And there we have this first car. Let's duplicate it once again with Ctrl D. Let me drag it to the right. By the way, I'm using here the move tool right here at the top. I'll also kind of put it right there so that we have some difference in between. And when we run the game, we kind of have something similar to what we want. But here the cars are not moving properly. I believe these ones on these last two tracks. Why is that? Because remember that we have told all our cars to move up. So this car in reality here, even though we have modified the sprites, it is actually going to be moving up, which continues to be this direction. So directly what we're going to be adding over here, okay, in between the constant and the variable, is another variable that is going to have the annotation of export. And this annotation is going to allow us to set this value or this variable value directly in the inspector, and you will see why this could be quite interesting. So we'll just call it var, and I will call it move down, okay? And as you can see here, we receive an error. Cannot use simple export annotation with a variable without type or initializer. So here we have to set specifically the value type. So in this case, we put a colon and bool in this case. A boolean is basically a type of value that can only have a true or false value. So what we simply want to do over here is to say, okay, if move down is equals to true, or which is the same if just move down, okay, so that you don't have to write all that. If move down, what we're going to be doing is this exact same thing. So Control X to cut it. I will put it right over there. If I want to move down, I just have to modify this. Or if move down is false, and the shorthand to write this is like that with the exclamation mark, this is the same thing as saying move down equals false, which would basically, if not move down, it means that we want to move up. So vector2.up. And now what we can actually do with this is that whenever we select a car, we're going to have this field of move down. So we can go to this car. So this is car 3, and we want to enable move down because this one should actually move down. This one should also move down. And we can now play the game and test if this is actually working fine. And as you can see, it's working perfectly fine. And it does seem that we have some kinds of game already finished. By the way, if you already have some experience or you don't find this code super clean, of course this is not a clean code, it should be optimized. But well, this is just a quick course, a short course for beginners, so we are not really going to be focusing on how to write clean and efficient code. For that, I already have more courses published. But if you really want to see like the correct version of it or a much better version, just let me know. However, there is one super important thing that our game is currently lacking, and that is the possibility of colliding, because I can directly trespass all these obstacles and nothing is actually happening. So first of all, what I want to firstly teach is that if we want to run the project, we're going to have this pop-up. No main scene has ever been defined, select one. So for this, I will super quickly go back to our scenes explanation, okay? So remember that in Godot, we can have multiple scenes. We can have one scene for our player, another one for our environment, obstacles, etc., even a main scene. This is exactly what we currently have in the project. But how does Godot know exactly which of all of these scenes should be executed first when you start the game? Right now, we are defining that by, well, opening manually that scene and then running it with this button. But in reality, if we wanted to actually run the project or export it and share it with friends, for example, we would not be able to do that. So for that, Godot has what is called a main scene. I know we have already talked about a main scene over here, but they are slightly or completely different. A main scene in this context basically refers to the scene that is going to be played, okay? Basically, among of all the scenes that you may have, the main scene is the one that Godot will execute firstly. And in this case, which is the main scene? Well, exactly this one, main scene, because we want our game to start in this scene. However, in a much bigger, well, not in a much bigger game, but in an actual game, the main scene may not actually be this main scene. It may actually be some kind of menu scene with some information of the game, such as the title of the game, okay, a play button, some settings also, maybe. Suppose that this is a gear, okay? That would be the main scene in a more complete game, just for you to understand the concept. So basically now when we press run the project, we can basically select some scene or select the current scene. In this case, the current scene is the main scene, as you can see, but if not, go to select the main scene, open, and that's it, okay? So now when you run your project, you should always be seeing this main scene in spite of being on tile map layer, or in spite of being on car, whatever. If you ever want to modify this, go to project settings, run, and here you can actually get to modify the main scene by clicking right here, okay? So now let's get to actually add the collisions, because that is something super simple. First of all, we have to think of which objects we want to collide. In this case, the player and the obstacles. So in the player, in reality, we even had a warning that we have mentioned at the very beginning of the course that this node has no shape, so it can collide or interact with other objects. We have to add a collision shape or collision polygon. Which is the difference between the two? It's quite simple to understand, okay? So C is going to be collision, P is going to be polygon. Collision shape is going to be S, and collision polygon is going to be this one. Collision shape uses what are called primitive shapes, basically squares, circles. You may also have spheres, etc. Okay, whereas in polygons you can create custom shapes. I don't know, triangles. You can also create more complex shapes, such as these ones. If you have like a more complex object, I don't know, maybe you have like a complete castle, okay, with like lots of things going on or whatever, you understand, well, you can create these more complex shapes. But what is important about polygons is that they take a lot of resources, basically. So its usage must be minimized, okay? And usually in Godot games, you're going to just be using collision shapes. Personally, in over 4 years, I've never used collision polygon, okay? But just for you to know that. So indeed, we're going to just be adding here a collision shape. So make sure that you have your player selected and add a collision shape. Make sure that it is attached to the player and not to the sprite or anything like that. And now here on the shape field, we can select, as you can see, all these primitive shapes. In this case, I really like to use, for example, circle shapes. Okay, because they are quite easy to set up. You just drag here the radius, and there you have it. And there we have it now, the project, the player with collisions. And now in the car, let's do something similar. Go to the car, add a new child node, collision shape, make sure that it's attached to the car and not to the sprites or anything like that. And once again, a new rectangle, for example, here could be the vest shape. As you can see, it's quite similar as setting up the visible on screen notifier shape. So we can do it mostly the same size, something like that's going to work just fine. But now we have something else going on, and that's the fact that yes, now technically these objects are colliding, okay, but we are not kind of doing anything with that. So in this case, to detect the collision, we have to go to the car node, and here we find the signals. These are called old signals that will allow us to detect the collision. And in reality, if you go to the player, okay, and you go to node, if you actually select the player, not the sprite or collision, because as you can see, these signals vary depending on the node. If you go to the player, well, you don't find any kind of signal related to collision detection. In reality, the only node that actually has all these types of collisions available is the area 2D. That's why whenever you want to actually be able to detect collisions with an object, you would usually use area 2D because it does have this kind of handy method of doing it. So in this case, we have, for example, area entered, area shape entered, body entered, or body shape entered. Which one of all these methods should we be using? This is a character body, remember, our player. So we have to use, in this case, body entered. Okay, body shape is other thing. So in this case, we want body entered. As you can see, emits it when the received body enters this area. Body can be a physics body or a tile map. And basically a physics body 2D, if we click over there, as you can see, this class, okay, this physics body is inherited by character body, rigid body, and static body. This means that with this signal, we can detect collisions with those three: character body, rigid body, and static body, which is perfect for what we want to do right here. So let's double click it, press connect. And here on body entered, what we have to make sure is that we are detecting the collision with the player. In this case, the only object with which the car can collide with is the player. Indeed, it can touch the environment, but the environment doesn't have any kind of collision shape, so technically the collision is impossible to happen. But in bigger projects, I just want to quickly show you how you can kind of define with which objects we are defining, and that is with the groups. So make sure that you have your player selected here on the left, not the sprite, not the collision shape, the player itself, and go to groups. And here just add a new group and call it player. Right there, and press OK. Now what we can directly do is go to a car script and do a quick check. If body.is in group, and here between quotes we put player, make sure that this is exactly the same name that you have typed in over here, player, and here player, so this is perfect. Here we can do wherever we want. So in this case, we'll just do a print, so we are going to show a message, collided, for example. And body, basically, it is exactly that, the body with which we are colliding. So if the object with which we are colliding is inside of the group player, which would mean that it is the player, we want to print that message. So now we can run the project and see what is going on. And as you can see, there we have it, okay? Once we collide with the car, we have the message being printed, okay? In reality, what we're going to be doing once we collide with a car is showing a corresponding user interface to be able to restart the game and do all that. Indeed, let's get in this new chapter to create the user interfaces. So mainly we're going to be needing 3 of them. They are going to be super simple to create. We're going to be needing one for when we win, one for when we lose, and also I'm going to be creating a super quick main menu. So to start with this, what we want to do is to select our main node and basically add a child node. And the type of node that we firstly need is a canvas layer. This one over here. What is going to actually allow us to do, sorry, the description here is not quite intuitive, at least for me. This is going to allow us to show this UI on top of everything else. Because remember that we have here like lots of things. So we want to make sure that this UI that would tell us, okay, you lost, okay, game over. We want it to be shown on top of everything else. And this is what the canvas layer is going to allow us to do. Remember that, for example, here the player is being shown on top of the tilemap layer because Godot firstly draws the tilemap layer and on top draws the player. If we put this over here, firstly Godot draws the player and then the tilemap layer, so it's not correct in this case. So to avoid all these issues, we have the canvas layer to make sure that what we put inside of here, mostly related to UI or only related to user interface, is going to always be shown on top of everything else. So directly inside of here, what I'm going to be adding is another child node inside of the canvas layer, and I'm going to create a control node. And this is going to be the type of node that you will have to use as a parent of everything else whenever you want to create a user interface. This will make sense in just a second. So I will call actually this one win UI of user interface. And as you can see, this has a size over here, but we actually want to cover the whole screen with this UI. So that's why I will set the anchor preset to be full rect. And inside of this control node, I will get to add the different components of it. I will start off with a color rect, which is basically a color rectangle. Once again, make sure that it is inside of the UI. And I will once again make it cover the whole screen. You can check here how this is being shown on top of everything else. This is the main advantage of the canvas layer. I will make this completely black, so I will just make it black right here, and I will decrease the alpha a little bit, just so that I give this kind of effect that is pretty that is worldwide used in video game development. So maybe an opacity of 200 is going to be more than enough. So I will just call this one background, okay, by double clicking on it. And I will say the uwin UI, and I will add a label, okay, to display text. We're learning lots of control nodes, but it is quite easy, as you can see. And this is the uwin UI, so it will be uwin. Okay, this is super small, so if we go to theme overrides, font sizes, okay, let's make this much bigger, maybe 100. And if you want to align this, you can just go to anchors preset, you can center it on top, and you can also move it down a little bit. So quite simple until now. And lastly, I just want a button to reset this. So let's go to uwin UI, add a child node. You can also use the shortcut Control A. I will just add a button, and I will put here reset. And to make this bigger, I will go to the select mode. I will just make this rectangle a little bit bigger, something like that. Theme overrides, font sizes, and maybe something like 70. And I will just center it. I know I have gone a little bit fast, but it's quite easy for you to understand this. The only things that we have done is adding the different nodes and positioning them. Quite easy, and always using this anchors preset, because well, it is quite easy for, as you have seen, to do everything. Now between here, this eye icon, I will just hide this one. I will select it and press Ctrl D. Okay, and I will call this one Game Over UI. I will now show this one, and I will just modify a couple of things. Instead of uwin, it's going to be Game Over. And the reset button is going to be the exact same one. Now let's also rename this button. So reset button and reset button, because what I want to do is to attach a script to them. So I will just save it inside of the corresponding folder. And what I want to do is to detect when I've pressed this button. So let's go to node, and once again, this is a signal, pressed, connect, and well, in this case, you can see it's being connected to the player. So let's erase this by, first of all, disconnecting the signal over here and deleting here the method. And once again, let's press pressed, but here we don't want to connect it to the player, to the car, or to anything like that. We want to connect it to the reset button. So there we have it. So on press, we want to just restart the scene. So I will do get tree.reload current scene, as simple as that. And now what I want to do is to also attach this script to this other reset button, okay? So let me just scroll down over here until I find my scripts folder, and I will just drag and drop the script to attach it to it as well. And once again, I will select the pressed signal of this second button, and I will connect it to this reset button, okay? So connect, and now everything should be connected perfectly. And lastly, our third UI is going to be the menu. So let's just go ahead and add a new scene. It's going to be, in this case, a user interface. So let me call this one menu. And what I will do, just to save some time, is to go ahead and grab here the label. I will press Ctrl C to copy it, Ctrl V to paste it. I will call it here just your game, for example. And then I will also go back to the menu node. I will add a child node that we have done, and I will create here just a play button. Okay, so I will just once again call it play button. I will resize it accordingly. I will center it, and now let me resize the fonts to maybe something like 75. Now I will add a script to this menus node right there, and whenever I press the play button, the only thing that I want to do is to change to the main scene. So I will do get tree.change scene to file, and here I will select with my arrows the main scene, and here enter. Okay, now what we want to do is to change the main scene, because when we run the game, okay, what is going to happen is that the main scene is being run, and we don't want that. So we go to project. Firstly, we have to save the menu scene, so let's save it there. Project settings, run, and here I will just go ahead and select the menu scene. Okay, So now whenever we start playing, we start right here, play, and there we go, okay? Now you have seen that here we have started with the game over being shown, so we don't want that. That's exactly how we want this to be. Both of the UIs hidden, and we will show them when we need to. So how we're going to be doing this, open up the car script, and here select the game over UI. Now just drag it, okay, with your left click over here. Do not drop it yet, so do not release the mouse, the left mouse button. Hold down Control, okay, and while holding down Control, just release the left click. This is what we're going to be having, okay, a reference to a game over UI, but the thing that we are interested in is the path to the game over UI. So let's just delete all these, and this is once again the reference to the game over UI, and I will just do .show, okay. Once again, if you are a more advanced developer, you may already know that this is not the best practice possible, but once again, this is a beginner-friendly course, and also a short course. You will then learn more advanced ways and better ways of doing this, because this is not a pretty optimal way of doing it. But while explaining a better system would take much more time. So as you can see, whenever we collide with the car, well, we do have the button here to restart, okay. I actually call it reset, but it should be restart, of course, so this is my bad. So in this case, restart, okay. We also have to modify it over here, so restart button right there, restart button, and we also have to rename this script. So this is not reset button. Let's right click, rename, restart button, okay. There we have it, and also here this text as well. But well, the thing is that when the game ends, well, the game kind of continues. So what we want to do is that that once that we have lost, okay, after showing the game over UI, we want to call get3.post equals true, which will basically do that. We'll post the game. Now, when this happens, we are not going to be able anymore to press on this button, because we have completely paused the game. So what we want to do is to go to game over UI, and in process, we want to, in mode, select when paused. This will allow these nodes over here, all these that have darkened, to be run when they are paused, okay. Because if not, if this is set to inherit, they are set to pausable, okay, basically. So if the game is paused, these nodes are not being executed anymore. So we must select these two, okay, and change process to pausable, okay. Sorry, not to pausable, so to when paused, so that they are indeed being executed while the game is paused. So let's press play, and as you can see, we can restart. But once we have restarted, well, the game has not actually been on pause. So when we restart the game, I will actually do it before reloading. I will do once again get3.post equals false in this case to unpause it. And like this, we do have like a much better logic to pause, unpause, restart the game, etc. Once again, I know that I've gone a little bit quickly, but I thought that now that you have more knowledge, you are able to follow along a little bit easier. But don't hesitate to go back, don't hesitate to lower the playback rate, whatever you need to understand this section. But well, I thought that it was quite easy, that's why I decided to teach it a little bit faster. So we also have to define when we're going to be winning, okay? And that's also quite simple to do. We're going to go to the main scene, and I will directly do it here, but you could technically do it in a separate scene and instantiate it then. I will show you a trick also with this. So what I want to do is to select the main node, and I will create a new area 2D, because I just want to create like an invisible area, basically, which would be the goal, okay? And if the player collides with that invisible area, well, we're going to be showing the game, the you win user interface. So for this area, I will just call it aim area, and I will just add a collision shape inside of it. I use the shortcut Ctrl A to quickly add the node, by the way. We don't need a sprite for it, because in reality we don't want this to be shown to the player, and I will just make it a rectangle, okay? Now let me move this aim area, okay, to something like here, using the move tool once again, that I have the shortcut also there, W. And let's just scale this in a little bit. So maybe something like this and like this. And now we should also reset the position of it. Always the children node, ideally they should be in 0, 0 to avoid any issues, okay? But if you must modify the children position, you can do it, of course. So whenever we collide with this aim area, so once again we need to take the collision with a body. This is the same thing that we have done with the player, but now we want to connect it to a script on the main area, but we have no script here. So firstly, let's attach a new script, go to to scripts, create it, and now we can go ahead and do body entered. Make sure they are connecting to the aim area, not to other object. And once again, we want to do here the exact same logic that we have done with our obstacles. So if body dot is in group player, make sure that the spelling is the exact same one. If we are inside of the group player, then what we want to do is to show this game over UI. So once again, let's drag it over here with the left click, hold down control, and while holding down control, release the left click. And now here we have the path to it. And I believe that you don't have to hold down control, right? No, you don't have to actually hold down control, because if you hold down control, you get the variable created. My bad. So game over UI dot show. And also when we do it, we also want to post the game. So get tree dot post equals true. And by the way, we also want to do it be after, just to avoid any issues. So I'm going to select this line, alt down arrow to quickly change the order of the lines. And now this is going to be done. So let's press play. We can die right there, or let's dodge these ones. And there we go. Okay, game over in this case, because I think that I put the path to game over. Yes, my bad. So you win, it should be. So you win dot show. Okay. And there we have it. We can move around. And there we have it. You win, and we can directly restart the game. You can also, by the way, now with the knowledge that you have, add the new button to go to the menu, which wouldn't be worth it because there is nothing in the main menu, but you could do it as well. So yes, I know that in this chapter I did go a little faster. It was a longer chapter, but don't hesitate to watch it again. You can even slow down in the playback rate the video a little bit if it was indeed a little bit too fast. But well, as we were creating user interfaces, we were just connecting signals around. I thought that we could go a little bit faster for those who have indeed been able to understand everything and you didn't want to spend a lot of time just creating some simple text and buttons. So well, indeed, this is going to be all for this course. I hope that you were able to learn a lot, to actually complete it. And just as a bonus, okay, for this course, taking advantage of the fact that, well, we are in 4.5 dev 1, which is currently the latest version. Maybe you have seen that while we are playing, we get to see these kinds of weird buttons maybe, but they are easy to understand than you may think. So first of all, if you go to input 2D or 3D, this defines what you can do inside of the game. So if you allow the game input, it is just that the game is running normally. If you select here 2D, this is going to disable the game input and will allow you to select 2D nodes and control nodes, which are the ones that, if you remember, are the ones that you use in order to create interfaces. So we can select this thing, and now if I want to move with the keys, I am unable to do it. So for example, let me select this car over there, and now as you can see, it has that kind of orange box. So what I can technically do is go to the inspector. Okay, and you will see that I have it kind of selected right over here, and I come back here to the game view, pressing Alt Tab, or also here going to Godot and just selecting it over here, and I should be able to see some information about it. But right now I am in its collision shape, and I actually want to get the root node. So with this option over here, I will click it again now in a second, and as you can see, I can select any of the nodes that have this car. So I will select car 3 in this case. And for example, I can get to modify the speed of it. So let's say that I want to test the speed of 3000 instead of 300. So this is going to be much faster. So let me actually try to do it right there. I don't know why this is not working, but maybe because you can't technically modify this right there. But for example, let's do other stuff that could be worth it for it right now. Well, but because this is a constant, okay, that's why you can't modify the value. But if we, for example, go back to the car, and make this a variable, okay? And we play again. And let's once again, well, I will change to input mode, and I will put it right there with this option to show a list of all the nodes. So I'll select car 3, which is the root node. And right here I have speed, so let's now set this to 600, for example. And now this third car, as you can see, is moving much faster. So it basically allows you to debug your game, to modify some stuff as the game is being run. And all these changes won't take effect once you close the tab. It is just for this game session. So you could also, for example, now modify the size of the car, okay, to be 2, so it's going to be much bigger, for instance. So you can get to see your things much better. Also, some other setting that could be interesting for you could be here in the 3 dots to disable, to make the game, to disable the floating window. So if you disable that and play again, you will have it here embedded. So this is much better to actually debug your game. So let's get back to input mode, and I will go back to 2D mode and select this car once again, and now I can modify it here much easier. So now once again 3000, let's try it again. There we have it, for example. Or let me now select this other car, right there, car, and this one I want to move I don't know, at much slower, at 50 of speed. So now this one is much slower. Or I don't know, you can do literally wherever you want with it. So it's quite interesting, this option that Godot 4.4, it was introduced in 4.4 if I'm not bad, allows you to do. So once again, well done, and I will see you in the next one. Bye bye. And also, if you want to continue learning Godot, I suggest that you actually do an investment and buy my 5.5 hour course, which originally is sold at $45, but using the link in the resources down below or in the description down below, you're going to be able to access it at just $13. So it is indeed a huge discount. Or if you even want to learn Unity, I have my own Unity course with over 22 hours of content, so we have a super complete guide to it, that once again its original price is $45, but using the link down below, you're going to be able to get it at just $13. So I hope we can see each other and that you can continue your learning journey there with me. See you there, and bye bye.